Yeah, so I'm Ben Sigelman. I'm one of the three co-founders at Resonance Labs. We're an early stage company, and we're really delighted to be at Heavybit. We are building what we call high-fidelity tracing, which is a core technology that can be used for many different things, and I'll show you a demo of some of those later. My background was at Google, where I built the Dapper project and team, which is a distributed tracing system at Google that has been given has some external presence because of a paper that we wrote about it. And I think of what we're doing for people who are familiar with that sort of work as like a much more flexible, much more robust, and I think much more exciting version of a similar technology. Yeah, I mean, everyone knows about this. I think probably every single Heavybit member company presentation starts with something about how application architectures are changing, and I agree. I would say if you or someone you love has a high concurrency application in production, they probably have like really profound visibility problems. We certainly do in our own system, and we talked to, I don't know, 50 plus companies over the summer in Q2, Q3, and I think 48 of them said that they were having like really severe problems with application visibility. I have a really lousy diagrammatic explanation of this. So yeah, this is really simple to understand and really inefficient. You do things in serial. Basic concurrency is, wow, you do them in parallel. Then you can do things asynchronously. This is sort of like a Node.js model where you're doing things in parallel but in pieces, and things are being moved across threads and rescheduled. And then, of course, you have what actually is happening in production, which is that, but it's happening on different machines at the same time. And the trouble is, if you look at any one of these things in isolation, which is what you're doing with conventional logging tools, it's sort of madness. Like if you log at high enough level of detail to actually piece together what's happening, it's like this fire hose of data, and the fire hose isn't even really telling you the whole picture because these operations are distributed across multiple processes. So what tracing is, in a nutshell, at least in the context of what we're doing, is being able to isolate one of these transactions as it propagates across the distributed system. To make matters worse, it's not just one thread. It's like these things are branching out into trees that are happening in parallel, and we need to track that as well. So that's at the core what tracing actually is. Another way of thinking of it, if this big blue box is your application, and this is the path that data takes to your application, maybe, 10 years ago, your application was divided into different libraries. Now those libraries have become separate components and services that have been split out. And the application data path is still happening, but it's been obscured by all these process boundaries and asynchrony. So that's a sense of the problem that we're solving. And what we've heard in the market, numerous parties, and I'm sure a lot of people here probably can identify with this, everything from just basic system understanding is missing. Like people don't know what's happening. Like a request comes in from the mobile app, they don't understand how it's propagating through the system, which makes it difficult to do pretty much anything. Or they have that level sort of somewhat figured out, but they can't do good latency analysis of these requests, or they have a crash at the bottom of their stack. They don't know how to explain what ultimate top user level operation caused that, and so on and so forth. These are the sorts of things that we try to think about. All right, well, I guess I'm halfway through my 5 minutes, so we'll move to a demo. So I recorded this earlier, and I was told that live demos are, asking for trouble. So this is a video of our product being used with a customer who is gracious enough to allow us to use their data for demos. They're running a pretty high throughput, hopefully low latency Node.js service that does kind of fraud classification on arbitrary data from their own customers. They initially they were having problems with long tail latency, which is, not surprising given the throughput that they're experiencing and the complexity of their service. And they tried to solve this with naive logging, and it knocked the logging system over. So they tried to write their own tracing system. It kind of knocked the tracing system over, and it also slowed their production application down by about 25%. So that was a non-starter. They would turn it on for like a few minutes at a time and try to get interesting info. They then talked to a friend who was in our pilot program who recommended our product, and they integrated with it in less than a day, and then, or actually less than an hour, I think. That's what he said, and they said this is saving them, quote unquote, a day a week in development time. So what we see here are on the left are operations that they've chosen to track in our system. For any one of these operations, you can assign an SLA, which is basically just an expectation for how long this should take. This is a user-facing operation. It shouldn't take more than 500 milliseconds. I'm willing to tolerate this percentage of operations that don't meet that threshold. I'm willing to tolerate this threshold of operations that have an error. After selecting a performance category, we're able to show 95, 99p statistics, that sort of thing. This is all like pretty straightforward, but very important best practice latency monitoring. And unfortunately, I think a lot of people do latency monitoring with averages, which is really meaningless. If we expand one of these things, what we see is a time series which illustrates the various percentile latencies over time, obviously. The histograms we have internally have many hundreds of buckets, and we have proprietary compression that allows us to do that at like a reasonable cost. But it allows us to be very precise about our measurements of high percentile latency, which is what most people actually care about if they're doing this right. What's most interesting, though, is if a user decides to go and select some time range within this graph, on the bottom you can see this list of links that's changing dynamically along with the selection. That list of links, each one of these is a trace, a distributed trace of an operation that was in that time range and in a certain bucket. And this is where we get to kind of the core technology we're building. We record a very high fidelity sample of what's going on, kind of on a continuous basis, and kind of like drop cam. If something bad happens in production, we can look back for a short period of time and actually collect a trace after it happens. This is quite in contrast to Dapper, which I did at Google, or Zipkin, or anything like that. And this is very powerful. It allows us to say, we actually want to bias towards sampling things that take a long time, which means you need to wait till the operation is complete to make that decision. So we can actually kind of stack this matrix with a disproportionate number of traces that are super, super long, super, super bad, high percentile things, or we can track a specific user and so on and so forth. You'll see how that works in a minute. So I'll open a couple of these in new tabs, and then we can go and look at one of them. So just to give an illustration of the sort of level of detail of these traces, so this is a single trace. The time flows from left to right. As you can see, this is about 4.5 seconds, this operation. This is a Node.js app. We basically instrument the core event loop, and if you use a conventional profiler on Node, what you'll end up finding is that you can help throughput by finding a hotspot within an application. Throughput is great, but latency is usually what you actually care about if you're trying to optimize user-facing stuff. And to optimize latency, you really need to understand the critical path of how data flows through an application. And our system, because of the level of detail we're able to grab from an application, we can actually automatically determine the critical path, which we highlight in yellow. So as I scroll down, everything you see here is on the critical path for the user's request. Here we've highlighted this particular time span, which is, this is not my application, but this relations labeler thing, this is what's holding up the user request. And this was like a 90 percentile trace. So this is what they need to fix in order to get rid of this class of problem. And it's important to note that even if we capture all this data without having the structure we have and being able to isolate this level of detail, it wouldn't be that meaningful. As I scroll up, I can show you the stuff that we're not showing in this trace. There's a lot of other data. All these little plus signs have many other spans underneath them. Some of them are quite large. So it's crucial that we're able to do that sort of sampling. This is an example of a trace of a slightly less problematic transaction, and then down at the bottom, just to kind of show you again how the sampling stuff can work and how powerful it is, we're actually dogfooding our own system here. This blue box is only visible because I'm logged in as me, as the developer of our product, and it basically shows us the option to trace the current page we were looking at in retrospect. So here I'm opening a link to that trace. So this is a trace of our own system that we made the decision to trace this after the event had taken place, and our system collected this after the fact with this really pretty fine-grained level of detail. We can log full SQL queries. We can log full payloads going over the wire, which I'm showing here. And this kind of level of detail is really powerful if you're a developer or a DevOps person doing root cause analysis. You can use a conventional metric system or possibly like an APM tool to figure out where a problem is. But if you really want to root cause it, you probably have to do it in production because it's very difficult to root cause. It's very difficult to reproduce production failures in dev without being able to see full payloads and so on and so forth. That sort of high fidelity information, it's difficult to understand why something is happening. happening. So our product helps with that. This screen is an example of what we can do with like tracking an individual end user. So here we're showing a page. We've decided to opt in to tracing everything this end user's ever done, which again is something we have to do is with after the fact sampling. We divide their history in this application into sessions automatically, and you can expand any one of these sessions and get a list of links to every single trace within that session. Each one of these traces, again, is, has that same level of detail, and this is a really powerful thing. Like a customer success person could say, hey, this company is having a really bad time with our product. Let's mark them in Trace Guide, which is just our code name. We're rebranding soon, but and get a list of every single thing this person's ever done in your system, along with the full distributed traces and all the payloads and database calls and so forth. So that level of flexibility is very exciting to the people that we're working with in our pilot program. And I guess my call to action is really not that much different than others here. I think it would be wonderful to collaborate with a lot of other companies at Heavybit on this. This is a natural integration for a lot of services that need to hand off to something that can answer questions about why things are going wrong. And we're also really looking to hire, especially people who aren't white males. Anyone know any not white males? We really want to talk to them a lot. So anyway, that's it for me. Thanks for listening.